This is strange being on video like this and being told you have 5 seconds. Okay. I'm Bill Sempf. I am a husband and father. My family, unfortunately, is not with me due to a series of unfortunate events, but normally they would be in causing trouble and whatnot. I have an 8-year-old son who would be having a ball here with the new family focus of DerbyCon and the surprising number of incredibly well-behaved and smart children we have here this week. It's been kind of thrilling. I am an author, though my authorship is probably of less interest to this group. My last book was Windows 8 development with HTML5 for the Windows Store. So that's a little outside the scope of what most of the people in this room probably do, but I've been writing for Rocks and then Wiley for the Dummies series since 1999. And have put out parts of or all of about 17 books. Not about 17 books, exactly 17 books since that time. My majority of my life has been spent working on something I like to refer to as a software composer. That is not my phrase. I got that from a book called Lorem Ipsum, which is a 137-page computer science book for children. And honestly, I learned more about computer science in that 137 pages than I did in 8 years of college. So I would recommend everybody to write that down and get a copy. But they describe software composers as people who take discrete sets of things and make more beautiful functional things out of them. And that's exactly what I did for a vast majority of my career. But this year, I've been this. Well, not really this. I'm actually kind of more of a vulnerability assessor. But I can't spell either one of those words very well, so I use Pentester. And I've been working in web application testing. And it's kind of a long story, and if you want to hear it, I'll meet you at the bar afterwards and I'll give you the story, because frankly, I can see about 12 people in this room I've already given the story to, so they'll get bored and it'll be bad. But that juxtaposition between 20 years of application development experience and a year of full-time testing web applications for security vulnerabilities gave me some interesting fodder for this talk. So that is what we're going to be talking about today, is that juxtaposition. In other topics about me, because why not talk about me for a second, I am a home brewer. Yay, I did not bring any. Boo. I am a lockpicker. I'm the administrative director of Locksport International, which is gradually declining in love and wonderfulness because Tool is so awesome. But hopefully we'll do something about that soon. I am a ninja. I'm 5th Q in Densetsukai Ninjutsu. Please don't test me. Please. You can only see me here because I want you to, though. That's what you have to remember. And I've been tagged as an insurrectionist, which is really funny. That introduction is largely from my development slide decks. And being an insurrectionist in the developer world is actually a bad thing, whereas probably every single person in this room would be tagged as insurrectionists if you were in the dev cycle. So it's less interesting than it was, but I am well known for saying things that nobody else wants to say at exactly the wrong time and project meetings and stuff. So anyway, that's neither here nor there. Let's talk about this, which is the Developer's Guide to Pen Testing. It's been pointed out to me that even though I thought about this title for a long time, that I actually completely screwed it up. This talk has nothing to do with how to pen test your own applications if you're a developer. If you're here for that reason, you can leave and I won't be upset. Though you will learn a lot of pen testing tips in this talk, but that's not what this talk is about. What this talk is about is how to have the talk with your development staff if you're a security-minded developer or a security professional or operations staff. You see, what I've learned is that security people think that the dev staff hates them. And they're right. The fact is that these two groups are very much at odds. In general, how many people here would consider themselves IT security, ops, pen testing, something like that? Okay, and I assume that most of the people who didn't raise their hands are probably just too lazy. So it's pretty much the whole room, with the exception of you, who's a developer. Yeah. That's right. So we have one. Do we have any other devs, pure hardcore full-time devs in the room? Okay, so you people are really here. You will not be bored with the talk, okay? So don't actually leave. If you're here at DerbyCon, you'll like this talk. So we're okay with that. Generally speaking, the security staff brings us poorly worded requirements that cost a whole bunch of money and don't do anything for the users. In general, devs don't like that. Okay? They don't like it. So what I'm here to do is teach you how to make the things you have to say to devs, because otherwise your whole system will become compromised, how to make those things more reasonable. okay? But first, let me tell you a little bit about where my path came from on this, outside of my introduction. I started out actually as an intranet admin for the first internet box at The Ohio State University, Magnus, back in 1992. And I was the coder among the operations people. I was the guy they went to and said, hey, Bill, write a bash script. It'll move all these emails from here to here. Okay, whatever. And then gradually moved into a more development role where I was kind of the admin among the developers. So I was the guy who knew how to run SQL Server, who knew how to run IIS, who knew how to reboot machines, who knew how to go in and fix routing problems, who knew how to do all those things because of my experience at OSU. I've had an interest in information security for a very, very long time, really probably the whole time, if you were to be honest about it. But realistically, for the past maybe 7 years, I've been the guy that is the security guy on the dev team. People kept coming to me to write the identity systems, to do the integration with LDAP, all those pieces. They kept falling on my plate. When people asked me, I've been an independent for 12 years. When people ask me what I specialize in, I say I specialize in security, integration, and performance. The three things that no dev likes to do. I actually like all of those things. But more and more, it was more and more security. And in 2010, I was writing the identity systems for OSU. Not OSU, the state of Ohio. I'm sorry, the state of Ohio with Dan King. We built they're going to do a whole single sign-on thing. And he and I designed that. Actually, Dan mostly designed it, and I wrote the documents, but that's neither here nor there. I took a left turn to write Windows 8 apps for a couple years, and when I came back to it, I reached out to the information security community and said, hey, I want to do some work helping people fix applications that have been determined to be vulnerable. Well, as it turns out, nobody really does that. That's work that just isn't really done. Other controls were put in place and stuff, but very rarely do people actually fix broken applications. So I ended up in testing, and I'm very happy there, so no major complaints. So from the perspective of a developer coming into the security community, there's a list that's very important and close and near and dear to my heart that I've been using for a very long time. Does anybody recognize this list? This is the OWASP Top 10, so I don't really need to go over it with you guys. This is kind of the core of this talk. When I talk to developers, I do follow the OWASP chorus pretty much just verse and chapter. I'm a big fan. I think they've, with the fact that nobody can really do anything right in application security because it's such a divergent topic, realistically, they're doing as better than anybody else at trying to describe the problems we're actually facing. So I use the OWASP Top 10 as a focus point for developers. When I need to point out why something is bad, or how to look for it, or how to fix it, I use OWASP materials to do so. So you may see some of those in this talk. But in my year of testing applications, which has ranged everything from super big banks that you would recognize to porn sites, and I kid you not, I have come across really 4 things that I've seen on almost every single application that I've tested. And those 4 things are information disclosure, injection of all kinds, configuration issues, and then kind of big super scoping ideas, which don't always fit into vulnerability assessments, but I make them fit because I think they're important for both the InfoSec team and the development team to understand. So this is the list of 4 things that we can do better. As devs. So I'm going to say we a lot, and sometimes when I say we, I'm going to mean the InfoSec community, and sometimes when I say we, I'm going to mean the dev community, and you're just going to have to deal. I'm sorry, because I'm really conflicted internally. So, and yes, I'm seeing somebody for that. No, I'm not really. So let's start with information disclosure. So, information disclosure is a really interesting thing because as the hardcore pen testers would much rather drop fancy ODAs that exploit these unusual bugs and network stack driver things and yada, yada, yada. But the fact is if the dev's going to give me the database password for free and then leave the database on the public machine, we're done. I mean, I don't have to do any work. I'm really lazy at dev, remember? So you're not going to come sit in the front row, are you? Yeah. Oh my God. Yeah, totally. So information disclosure is very, very important. And as an InfoSec staff, you have really 2 choices of things to do. You can teach or you can use the clue stick. because there's really no other way to fix these problems. You can, yeah, okay, you can use egress filters and stuff to try to prevent things from leaving your company, but I've seen that and it sucks. So we have to find ways to explain to the developers why things are bad. All right, why information disclosure is bad. So let's just rip through some of them that I've seen before. Server headers is a great example. One of the things that interests me about developers and server headers is developers, and we'll talk about this several times throughout this section, but developers like to brag about what they do. They like people to know. They like people to know what they're doing, what technology they're working with, what platform they're running on. They want people who can understand to understand. And it's a pretty reasonable thing. But the fact is that an automated attacker is going to use this information in order to better determine what attacks to bring before against the server. Okay, so this doesn't even have anything to do with the application. Explaining that you're weakening the server infrastructure by allowing this information to be on the box is kind of a big problem. And the thing that I've brought to bear more often than not is just to go to the CVE list and look it up. Just like how many pen testers do I have in here actually? Actual full-time pen testers? Oh, not that many. Okay, well, but all of you have seen a vulnerability assessment. So, I mean, when we go and we write up somebody for using old software, this is the link we give them in the report, right? We just link to the CVE database and say, here's all the vulnerabilities that we know happen in this version of this software, so you need to upgrade, and by the way, you should probably stop telling me what you're using. Devs don't like to upgrade software, but they need to. It breaks their code when they do. When they upgrade the underlying software, it breaks things. They don't like that. And it's not just PHP. I'm not going to pick on PHP in this talk, even though it's got some problems. Ask.NET does it too. They are just as likely to have just as many vulnerabilities in .NET as anything else. Developers like to brag a bunch. One of the most interesting things I've learned in changing from development to information security is in development, you always talk about your projects. You go to a con like this, you say, dude, I'm working for Chase. I'm building this awesome thing where you log in and it'll tell you if your bank balance is low, and it's just awesome. And in the information security thing, you say, yeah, I had this client once that did some stuff. Yeah, you can't talk. You can't talk because not only are you under 1 billion NDAs, but you genuinely bring people at risk. If you say, yeah, I was doing a project for Chase and I found the SQL injection vulnerability, that's also information disclosure. But devs like to brag. They like to put their name at the top of their code block. Why? Because it's like a fucking work of art. Okay? They've worked a long time to write this code, and they want people to know what they've done. The problem is you can pick the name up off the line of code, and you can look it up online, and then you can find where they asked about how to use the database. Okay? And then you can find out what software they're using underlying. And that just leads on a directed attack. That just leads to bad places. And it's not just commercial or corporate enterprise software either. Open source headers provide a pretty easy method for attack too. Now, as a dev, I can look at what files you've chosen and that are sitting in your JavaScript directory and whatnot, and determine what underlying tools you're using. But the fact is that an automated attacker couldn't. But an automated attacker can read the headers of your open source files that you have sitting in your directories. So getting that information out of those files is important. That can happen in deployment. We'll talk about that near the end of the talk. So we talked a little bit about developers bragging and leaving their development information leaving their development, their name and email and stuff at the header of files. Why that becomes interesting is because developers like to get help. Sometimes they like to get help from open source software, which doesn't always work out that well because sometimes open source software has vulnerabilities in it. But that's neither here nor there. Most of the time they get help by going to places like Stack Overflow. Now, if you're not familiar with Stack Overflow is an awesome, basically question and answer format with invisible internet points that don't count for people who answer questions and people who ask good questions. Stack Overflow is fantastic because people work very hard to craft very careful questions. Otherwise, the questions get thrown away. It's not like Usenet. It's very carefully monitored by a very, very picky, anal retentive community of people. And the more imaginary internet points you have, the more power you have in the forum. So people who are really good at answering questions can decide that your question isn't good enough and throw it away. So people work really, really hard to put as much detail as possible into their questions, including their database passwords. Now, that's funny, but actually it's really not. Really not. Because if I'm looking at your website and your developer name is in the comments, and then I go to Stack Overflow and search for him and he's asked this question, it's game over in 2 Google searches, people. 2. That's ridiculous, but it's true. Information disclosure is a real problem. So that's where I go at. Developers use Pastebin a bunch too, and they do the same thing. Developers use Stack Overflow to communicate with people they don't know. They use Pastebin to communicate with people they do know. Okay, so hey, take a look at this clip of code and see what you can do to fix it. And it also has database password in it somewhere, right here. All right? Very easy to find as an attacker if, once again, you know, for instance, the database name, which you might have found out of a Stack Overflow post that was maybe better redacted. But in a Pastebin post, they did put the password in. Sometimes people put really, 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 really stupid things in Pastebin. But that's neither here nor there. Let's talk about exposing internal services. This is a big topic for me, and I need you to bear with me for a minute. I can see some of you already have that 6 o'clock, but just hold on with me for just a little bit longer, because this is really important. You're good? All right, you're good. That's good. That's what I like to see. In the 90s, we started developing much more componentized software. I was a Microsoft dev. We built COM software, okay? So we have a database with a data layer, usually written in C++, and then a business layer, usually written in Visual Basic, and then a front end, also usually written in Visual Basic, or maybe Power Builder or something, in the Windows business world. Okay, in the 2000s, we started to work on something called SOA, Service-Oriented Architecture, which we used one of 2 web-based standards to make web servers provide what we used to do with a very strictly formatted Windows-style communication methodology we did before with COM and DCOM and stuff like that. We did in an open standard. There were 2 of them, SOAP and REST. Okay, there still are. SOAP is not just the stuff that you should be using every night to make sure we don't pass out in the morning. It is also a standard for a web service. That was not you, by the way. I hope you caught that. REST is a slightly, well, it's both older and newer, but it's a slightly more, it's just the bare bones of information. So SOAP is Martin Lawrence, you know, with all the stuff, Big Mama, and then REST is just Martin Lawrence. You get the idea? So to make it a little bit more technical, this is a SOAP request. A SOAP request has to be in an envelope, and then in a body, and then you have to put a method name, and it's all in XML, and all of us hate XML, right? So it sucks. So this is a request to get IBM stock price right now. This is a REST request to get IBM stock price right now, okay? So I'm not trying to poke fun at SOAP or REST or anything. SOAP is actually very useful because you can do other things like security, for instance, which is totally gone from REST. All REST does is do request response with very, very basic parameterization. SOAP you can do all kinds of things with. You can do transactions, you can do security. It's very powerful, but it's also very meaty. You just needed to know that in order to know the next part of the story, okay? So what had we done before? We had done COM, right? And then we had done web services. So enter the mobile era. So this is 2005-ish, right? Everybody's starting to carry a mobile phone that can speak internet, right? Smartphones became popular. So what did the boss say? The boss said, we have to have an iPhone app. Dev team, go make that. And the dev team says, oh, we'll just use the stuff from the web app. Oh, wait, I should rear it around its sides. All those services are awesome, but they're actually behind the web server, behind the firewall, and the web server is sitting in the DMZ. We need the web services to be in the DMZ so that the iPhone can speak to the web services that used to be just in our internal network, right? Is everybody following me here so far? Yeah. Okay. So what did operations do? Operations said, oh, okay, well, we'll just push the web services through, no problem. Ta-da, right? That is a real bad problem. Those services are very rarely vetted by your security teams nearly as in-depth as they would be unless you work for one of the big companies with PCI and HIPAA leaning over you and have big-time standards. If you work for companynormal.com, those services are very rarely looked at with any rigor, and now they're sitting on the open internet. And people, and the developer, I'm here to tell you what the developer thinks, right? The developer thinks they can't see those services. They have to use the iPhone UI, which I've composed very carefully. No. So we all know that's not true, right? I'm getting a bunch of blank stares. What can we use to go touch those services? Well, anything, really. But what's best? Is an attack proxy. I mean, the same thing we do if it was a REST website. The difference is a REST website, at least some of the information, presumably the most carefully controlled information, is pre-processed before it gets to the web server. Okay? Now we've taken those back-end services and put them all the way out so the iPhone can see them. They probably have not been pen tested with the vigor that the existing external web services have been pen tested. That is a very bad deal. You find things like the WSDL sitting out there, which doesn't do anything except for give you the entire database structure. No big deal. Okay? So this is something that often has happened in my experience over the last, this is just a year of working in this, okay? But in my year of doing this so far, I have seen maybe 5 times on tests where services have been exposed for either mobile applications or Ajax-driven websites where the services that were exposed were not properly vetted by anybody in the security team. Look for it. The attack surface is massive. It's a whole talk into itself. I'm not going to get into it. But everything you can do with a website, you can do with a web service in spades. So don't overlook it. Any questions about that? Good. Let's talk about exception management. This is a real common thing that not only do the program managers and testers not like, but you as security people don't like either, right? You don't like to see raw exceptions on the page. Nobody likes this, right? And I'm not going to pick on PHP. .NET does it too. What the developer doesn't know is that an attacker or an auditor or pen tester is going to throw an extremely high level of bullshit at their site through an attack proxy in order to break it, which means it will not be going through the HTML of the website, which is what the developer has tested. The developer and QA have tested the application through the UI, which has all this JavaScript control. Is the attacker or the pen tester going to use that UI? No, they are not. They are going to use burp attack proxy to do that, and they're going to bypass any controls that are done in JavaScript. So they need to understand that exceptions are going to occur for things that they were not prepared to handle, okay? So what they need to do and what you need to tell them to do and make sure they're doing and look at code review and talk to the team lead is structured exceptions. What does that mean? That means if I promise you cookies and, I'm not going to give you diamonds, sorry, cookies and coffee, but I have an exception giving cookies, I will apologize for the cookies not being there and still give you the coffee, okay? Let me explain that. This is some C# code, okay? We are going to try to get cookies and coffee. If it doesn't work, we are going to apologize, okay? Now, see this here? This is a generalized exception, all right? So this says, if I have an argument null exception, which is C# talk for saying the thing I was trying to look at is actually null, and I don't like nulls, I'm going to do something very specific. But no matter what, I'm going to apologize if anything goes wrong. Does that make sense? That is extremely important. Developers are very picky. They like to be specific. They like to explain things to the user exactly the way they happened. They still need to be ready for generalized crap to happen. But people can't send 65,000 characters to this field. I'm preventing it in the UI. The attacker isn't using the UI. They are using an attack proxy. Oh, okay. So we need to do that. So here's some Java. This is finally. This is saying, even if I can't get you your coffee, or your cookies, I'm still going to bring you coffee. Okay? Finally is run no matter what happens in the try block. But what's missing in this particular one? There's no apology, right? There's no catch. So what you really need, here's a PHP example, is all three. The try block is the stuff that gets executed. The catch block is catching an exception. This is a generalized exception in PHP. And the finally block is going to be executed no matter what. That is a structured exception, and that is the way every piece of middle-tier code should be written in your organization. If it's not being written that way, somebody's going to find those big ugly exception blocks and get information about your back-end systems. Worst case, you get owned. It's still a bad case, but best case, you'll get written up on your next pen test. So the developers need to understand that exception management isn't just something that's done when they think something might go wrong. It's done all the time. Even web services fall into this category. SOAP, so REST, you just can use as HTTP error codes, right? 500s and 400s and whatnot. In SOAP, there's actually a fault class, a fault, I don't know, what'd you call it? A fault instance, I don't know, a fault node. Pretty much everything that generates salt can do for you. So even in web services, you can return the proper error controls to the front-end system. Any questions about exception management? Let's talk about injection. I'm not going to talk a bunch about injection. Yes, I'm sorry. Yes, that's a good example. That's probably what this example is from. The question was, what if you're trying to just let the exception bubble up? That's awesome, as long as it doesn't bubble up to the browser. Yeah. I'm actually a big fan of that, just making the UI layer catch everything. I'm a big fan of it, but it's gone out of vogue, and I get yelled at a lot for it. So I'm not going to talk about injection because injection's been on everybody's lips for so long, it's not even funny. But injection is injection to a backend system or injection to a front-end system, right? So SQL injection, LDAP injection, operating system injection on the back end, cross-site scripting, and some other things occasionally on the front end. So what do developers do wrong? Developers do not sanitize inputs. Why do developers not sanitize inputs today on web applications? Because they think that JavaScript sanitizes inputs. Does JavaScript sanitize inputs? No, it does not. Do not let them convince you that this is the case, because just because the user using a web browser can't type it in does not mean it cannot be sent back to the web server. Okay, a demo of Burp or Zed will cure them of this most of the time, at least for a few weeks until they forget. They fail to sanitize outputs. Sanitize outputs, you say? What are you talking about? We've already sanitized the inputs. That's the problem. Devs have blinders on. When a security professional, well, I'm talking to mostly InfoSec people, so when a pen tester gets a project, it's like a week or 2 weeks, okay? It's very short. When a developer gets a project, it's like 18 months. So you really have to put the blinders on, all right? All you see is your project, your app, your users, your cards, your requirements, you, okay? Or your team, maybe a little bit bigger blinders. But they're still, you got the blinders on. You don't realize that actually this is an enterprise application and the data is coming from many other places. Developer XYZ down the street did not sanitize their inputs. Therefore, you are still delivering cross-site scripting to your users. Bad juju. Bad juju. So, sanitize inputs, sanitize outputs. Encoding is a whole nother thing. I didn't put it in here because it's a whole presentation into itself. Go look, there's an encoding cheat sheet on OWASP's website. Search for encoding cheat sheet, I think, and you'll find it. I haven't tried that in a while since they moved to the new platform, but I think you can find it. If not, come find me and I'll find it for you. Or I'll put it on my blog or something. Anyway, so what else do developers do that cause injection problems? On the back end, they avoid ORMs. ORMs are object relational models like Entity Framework or Hibernate. Okay, they are cool little things that you can describe what your data looks like in ephemeral terms, and then they map it to the database for you. Okay, now previously we would tell people all the time use parameterized queries, but the fact is that they got tired of writing all the SQL statements, and I don't blame them. Well, I was one of them. You can't keep up. You can't keep up. You'll be in the database every day if you try to write SQL queries, actual stored procedures for everything you're going to do. There's just no way. And trust me, for 15 years, I was the one standing up saying, write parameterized queries, but no more. Use an ORM now. They're just too good. Entity Framework is open source. It's good if you're in the Microsoft stack. Hibernate has been around for, 20 years? And maybe not that long, but a long time. It's really good. There are other ORMs out there that are cross-platform. There are ORMs for Ruby, for Python, for Rails, for PHP. The reason developers don't like to do it is because of not built here syndrome. Okay? They don't like to use tools that other people built a lot of the times. Now you say, but somebody else built Rails and you're using that. Why won't you use the... But no, they won't like that. Now this is going away a little bit among the Rastafarian kind of more hippie-ish sort of Ruby, Rails, Python web people that are a little bit more software craftsmen because the open source thing has gotten so good. But on the enterprise side, when it's Java and ASP.NET, it's like, I'm going to write that myself. And it's seriously, that's what they do. And it's a disaster because they'll miss things. And then you have this huge framework you have to test, and it's a mess. Just use what comes with the platform. And I don't have a good tip to what to tell the devs, except for don't do that. I'm sorry. On the front end, developers are still using eval, and I do not know why. DOM XXS is a real thing, and I mean, I've gotten to the point now where I will search, I will map a site with burp and then just search the JavaScript files for eval paren, and if it comes up, then I will write them up for DOM XSS, just figuring that I'll probably be able to get the evidence later because it's just so easy. It's ridiculous. So, and DOM XSS is real. I don't know where you guys all are on your takes on vulnerabilities. Everybody has a different take, but DOM XSS will end up with the attacker having your credentials. So it is something people get written up for, and it's a real thing. Hi, Jason.
Hi, buddy.
How are you doing? I was wondering whose that was. Excellent. You can have that, yes. If you're in the XML world, a failure to use a DTD is a big deal. Okay? XML entity injection has caused the only 3 pure owns of servers I've ever done. Now, the reason why I don't call myself a pen tester is because I don't know anything about post-exploitation at all, okay? Like, I kind of know how to use Metasploit, sort of, but I mean, if I were in a machine as the admin, I'd be like, yay! Oh, I'm going to clean up some code here. Seriously. I don't... Sorry, it's true. I mean, I know... I've been coming to these cons for... This is my 3rd year speaking at DerbyCon. Can you imagine that? I know theoretically what to do, but I'm not practiced at it because I've never done it. I find the vulnerabilities. I don't do anything with them. But the 3 times I've actually owned a box has been because of XML entity injection. Because you just can upload whatever the hell you want. So use of a DTD will prevent this. I'm not going to go into big depth about how a DTD works and what it is because that's also a whole other presentation. The devs will know. Put it on your list for things. I'm going to publish next week the white paper that goes with this. It isn't done yet, but it will be. It'll be up on the blog. I'll see if I can get the DerbyCon account to retweet it for me. And you'll have all these in a nice bullet list, so it'll be good. And the last thing is the devs tend to play fast and loose with JSON. I think I mentioned, that sounds kinky. I think I mentioned that the devs that use the REST and very Ajax-y, they tend to be a little bit more craftsman-y, very theoretical in their development practices. I'm doing for time, good. They will tend to treat JSON very lightly. And it's kind of scary because JSON is very injectable. If you bypass, it's the same problem with the web services being injectable with XSS, right? Just a quick tip. You can fix a lot of JSON problems by just putting a no-sniff header on your server. If the attacker can't have the web browser use those API calls some other way, then it'll never be exploited, even if there is cross-site scripting in there. So you can in operations you can fix that, but in reality you need to see if you can prevent developers from making those mistakes of playing so fast and so loose with JSON. Any questions about injection? Let's talk about configuration. Developers are too often in charge of their own production servers. I recommend not doing that. 20 years in dev, seriously, just don't. Build a deploy process and do not give the developers the key to the prod server. Okay? Devs like to do things like leave files around. Now, we all have source control now. Everybody's using Subversion or GitHub or Git, and it's all wonderful and great. But the fact is devs like, oh, I'm not going to check that in because I don't want somebody else to see how the sausage was made. So we'll just keep it here on the web server. And then what happens? It gets checked in. Well, that's a bad screenshot for that, but it gets checked into the prod server. Now, obviously, if you don't do things like leaving your directory browsable and stuff like that, a lot of bad things won't happen. obviously, right? If you can't look through the directories, it makes it harder. But we do a pretty good job of guessing, don't we? I mean, it's pretty easy to guess the names of files. Also, we have these wonderful things like robots.txt files that will give you all the places you shouldn't go look. Devs love to use those to say, oh, I'm going to put this file in there so that nobody can see it. No, I was one of those for a long time, so I shouldn't laugh. Another thing that needs to die is a sitemap. Does anybody even use these things anymore? But a lot of the web dev tools generate them by default and publish them up to the web server, and then, oh, look, there's, login.aspx.back. Gee, I wonder what that's for. Oh, it's for me to go and look at the logic for the back. Oh, great. Oh, look, there's a comment with the administrator password. Yeah, that stuff happens. Devs leave stuff around. They leave stuff to remind themselves. They leave stuff to be there. Introduce them to the content discovery wizard in Burp. You can do a little configuration. You can run the wizard, and it will go through and test all of these well-known standard iterations on extensions and file names and stuff, default1.asp, and all those things that you test a couple of times with your fingers when you're just making sure things are all right, CTP or CTF rather, or whatever. It'll do all of them, and it takes forever to run, but it's pretty neat. And then what it does, it fills up the sitemap for you. It'll go in and populate all the files that it knows are there or it thinks might be there. If it's black, it's a file that it's actually found and worked with, and then it will interpolate from hrefs it finds what else might be there, even if it hasn't had time to go get it. And then you can just spider from there and scan from there, and you can get a lot of good stuff. So this is one of the things that is very commonly, I've run into very commonly, is .bak files I referred to earlier. Visual Studio makes them by default. And the developer might not even be at fault here. If Visual Studio crashes, it will often make the .bak file, it'll take the tilde off the front of it, so that it leaves whatever changes the developer was working on in situ, and then supposedly it'll restore it and then delete the old file when it comes back up. But if something goes wrong when Visual Studio comes back up, it'll leave the .back file there, and then the dev will publish it. Not because they mean to, just because it's there and they publish everything. And then, of course, the IIS doesn't know what to do with that file, so it just delivers it, code and all. So information disclosure bad. Ugliness is not good. Something else that devs like to do is turn on file permissions. I can't see this page. It doesn't run for me. What do you mean it doesn't run for you? It runs for everybody else. It doesn't run for me. Okay, I'll just put this web directory in the everyone group. Yeah. So that's kind of a bad thing. Remember, they're often doing this just to solve a problem. Okay, and we'll get back to this in a few minutes. But what they're trying to do is solve a problem for a user, okay? They're not trying to make your life difficult. They just are making your life difficult. So let's talk about some big ideas, okay? So there's some big ideas that we have to, actually some of those earlier things have kind of rolled up into. A lot of what the developers are trying to do is make debugging easier in production, okay? Now, some of you may be in operations and maybe you do get calls at 3 a.m., but developers always get calls at 3 a.m. When the batch job doesn't work, the manager gets paged, he looks, there's an exception in the event log, and he makes a phone call to the dev. And I'll tell you what, there is nothing that sucks worse for a dev. They do not like to be on call. They do not want to be on call. What's worse, they don't like to be on call if they can't fix the problem once they've been called, because they can't look at the prod server, so they do things like leave trace on. Now, leaving trace on is a really horrible idea from the security perspective, but what the dev is just trying to get production working again. And once again, I don't mean to pick on Ask.net. There's lots of places that have debug modes that devs will often just say, you know what, screw it, I'm just going to leave it in this mode when I deploy. In operations, you need to turn these off. But you need to find a way, working with a vendor that's appropriate for your platform, so that the developer can debug in production. He or she has to be able to do that, okay? That's not an optional thing. Don't think that because it's passed all the QA tests and everything, that it's going to go to prod and just run. It won't. It will break weekly. And the dev is the one who has to fix it. Help them find a way to do their debugging other than turn tracing on, okay? Something else that's a big idea is build your own in general. Encryption is a big topic. Developers, great story about developers and encryption, right? So I had the guy that on a project maybe back in, 2002, 2003 at the state of Ohio. And I said, hey, I've never seen this hash before. What did you do? Oh, This is awesome. My lead dev, man, he's so smart. He wrote his own hashing algorithm. He's got like a chess rating of 9 or 1800. He's the smartest guy. Nobody can even figure out. We look at the code, we don't even know what it does. It took me about 30 minutes to reverse the hash, and I do not have a chess rating of 1800. Okay, developers who think they can write their own hashing algorithm are only writing a hashing algorithm that they cannot reverse. But they're not doing it because they're bad people. They're doing it because they like a challenge. And they think, wow, I modeled this awesome big business process here. But what they have to understand is that hashing algorithms and encryption in general is an order of magnitude more complex. Okay? No matter what you do, it is very unlikely that we could take every developer in company X, put them in a room, they still will not be as smart as this guy, okay? There is nothing we can do about it. If they have more questions, refer them to the SHA-3 process, okay? So this guy wrote Skeen and then pushed it through the SHA-3 process, and it went through 5 years of testing. 5 years of testing, made it to the final 5 and still didn't win. All right? So if your hashing algorithm written by your chess grandmaster has gone through 5 years of community testing from cryptographers who are put in white rooms with bare bulbs and beaten with wire whips to come up with this shit, we're golden. Otherwise, use AES, or well, AES, yeah, use a hashing algorithm that matters. Use an encryption algorithm that matters. They're standardized for a reason. Okay? So that's a very important thing to come across to the developers. Something else that's BYO that really starts to get me, and this is me. This was me 10 years ago, building your own identity system. So what's an identity system? It's where you log in with your username and password and it remembers your roles and shit, okay? 10 years ago, there was a good reason to build your own, because there wasn't any, okay? Today, there's no excuse, okay? With OAuth for basic authentication, all the way through to federated identity, Active Directory, the SQL membership provider on the Microsoft side. There's hundreds of examples on the open source side. You don't need to build your own membership provider anymore. What happens when you build your own membership provider? This shows up on Pasty. All right? And that's what you need to point out to them. But they're going to say, no, I can do better than that. SQL membership provider has this thing where you can only have roles that match up with the thing and the other thing. I don't like that. I'm going to build my own. And you say, listen, see this big red line? That's how long on this project is going to take you to build the identity system. You do not have the time. That is where you get with BYO. That's where you get it with injection. That's where you get it with everything. You have to force the angle of, listen, the open source community is very rich and strong. Even the commercial community is very rich and strong. Use them. You do not have the time to build this crap. You can get good stuff that you can modify for free or cheap. Use it. And honestly, most of the time we'll listen, frankly. So where does that leave us? Security professionals need to treat the security needs of an application like the requirements that they are, okay? If you go to the dev at the beginning and say, by the way, encoding your inputs and outputs is a requirement of this application because it's in PCI, you know what'll happen? They'll do it. But you gotta put it up here. If you tell them here, you're fucked. Because it takes too long. Add the vulnerabilities you find to the bug tracking system. If you walk into your lead dev's office and hand them a vulnerability report, they will take it to the toilet and use it for what they think it should be used for. Okay? They do not want to see that. Vulnerability reports do not tell them how to fix things and do not give them any real impetus to solve a problem. Add security vulnerabilities to the bug database like the bugs that they are. Make sense? All right. Educate yourself about the third-party applications and components that your developers are using in their applications. Are the website that is under your control as a security pro, is it using jQuery? Do you know jQuery? Do you know what jQuery is about? Why not? You should know. You should know what the vulns are. You should know how the plugin model works. You should know what the community model is like. Get educated. The dev community, security community has been telling the dev community for 10 years to get educated about security. Sometimes the security community's got to get educated about dev. Learn about the third-party components you're using. Keep an eye on Google. Set an alert for your database names, your server names, your developers' email addresses, company email addresses. Keep an eye on things. You'll be surprised what you find out there. Trust me, you'll be surprised. Use deployment scripts to get the sites from QA to prod. Those deployment scripts, get rid of all the comments, get rid of all the backup files, get rid of all the extra crap that's in there. Just move the stuff that has to be moved. You'd rather break it overnight anyway and have to tweak it than have the security vulnerabilities, okay? Once they're set, they're set. Use them. They're very easy to build. How many people went to the PowerShell talk earlier? Nobody? Oh, a couple people did. Okay, I've just bored you all, and you've stopped raising your hands. Or you're writing. Some people are writing. That makes me happy. Use deployment scripts. But honestly, the last thing, stay involved. Don't just be the person who walks into the dev guy's office and drops the vulnerability report on his desk, okay? Get involved at the beginning of projects. Tell the PMs, hey, I want to be involved in scoping meetings. Okay, talk to the devs. They're not bad people, okay? They know they make mistakes, but they really do want to do the best thing for the user. That's what devs want to do. Their payment is happy users. Yes, okay, they get paid money pretty well too, but they like happy users, all right? You need to remember that they're not your enemy. You're all working together to make a better environment for people, okay? So that's the happy-go-lucky talk here. For this part. Hey, there's all my bullets. I was wondering why there wasn't any bullets in this presentation. I'm at Sempf on Twitter. My name is Bill Sempf. If there's any questions, you can ask now. Otherwise, I'll be sitting at the bar CTFing for the next hour or so if you want to talk to me there. We've got we really should start changing, but if you can come up here and ask me if you want to ask me. Or you can ask me on Twitter, because I'll check the Twitter in a little bit. And that'll be kind of public. Thank you very much. I'll be enjoying it.